Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada the Engineer. With me, Mr. Lady Ada on camera control, decider of the code, and all-around good guy.
Or not.
Yeah, we've got a fun show for you tonight. Lots of new products. It's coming out soon, and some videos, as well as chit chat about Python, INPI, and more. Mr. Lady Ada, why don't you tell them what's the code and what's on tonight's show?
Tonight's show, the code is TRRS. It'll make a lot of sense in a few moments as we get to new products.
Yeah.
10% off in the first all the way up to 11:59 p.m. Lady Ada will talk about the free stuff in just a moment. Go over some of our live shows, including a highlight from JP's product pick of the week. We'll do some Python on hardware news from our newsletter, Adafruit Daily. We got open source hardware guides and more from our products from learn.adafruit.com. We got some advanced manufacturing, a glimpse into the factory here at Adafruit. We got some 3D printing videos, a speed up and more time lapse. Got INMPI this week is
Infineon.
brought to you by DigiKey. Thanks, DigiKey. We got a couple top secret videos and a couple products for Lady Ada to show. It's not out yet. Don't ask. New products. We answer your questions. We do that over on Discord, adafruit.it/discord, discord.gg/Adafruit. All that and more on, you guessed it, Ask an Engineer.
Dun, dun, dun.
Okay, so first up, code TRRS. This is how we fund Adafruit, a loan-free, privately held.
No private equity.
Don't do ads or anything. We don't do AI. All the things that people are grumpy about, we don't do, but we do sell hardware. So that's how we pay our team and give them benefits and all the things that they need to live good lives. Your hardware supports it. What do they get when they add to the cart? And just keep in mind, this is USA only now because internationally it's hard to add stuff to orders because there's tariffs and taxes. So this is USA only.
Yeah, it was actually holding up people's packages, and so so freebies.
Times are changing.
Yep. So eventually we just had to say for US customers only, you get free stuff when you order stuff from Adafruit.com. $99 or more, you get this beautiful PCB coaster with a gold Adafruit. $149 or more, you get the KB2040 featuring the RP2040 chip with Stemma QT, buttons, NeoPixel, 8 megabytes of flash, USB-C, and castellated pads. Free ground shipping for US orders, $199 or more, and $299 or more. Still giving away our free Circuit Playground Express all-in-one dev board. It's a great way to learn programming and electronics without needing any tools.
Okay. We have a bunch of live shows. Show and Tell just happened. Thank you, Melissa, for hosting. We're gonna watch it as soon as we get off air. I know Bill stopped by and showed off some of the things that we'll be talking about later tonight with some assistive tech and more. On Sundays, we do from Just Lady Ada, including The Great Search. And then on Tuesdays, we do JP's product pick of the week. Here's this week's highlight.
IR receiver Stemma breakout board. So what's happening is when I press, let's say, the volume up button, you can see my IR receiver back here is receiving that signal, and then it's telling my display to show a different piece of text. You can see the little two receivers there, horizontal and vertical, and the little switch there for flipping between the two. There's the backside with the little jumpers that you can cut. Here is the IR receiver, and it's plugged in with one of these double JST connector Stemma cables. And then I'll bring my little IR remote in here. If I press up, down, left, right, you can see the little receiver LED blinks there when it receives a signal. It also has the power LED on there. It is the IR receiver Stemma breakout board.
Okay, and then tomorrow's JP's workshop, and Friday is deep dive with Scott. All right, Python on hardware news this week. We've got a very specific one that we want to help get the word out. If you like PyCon and you like CircuitPython, guess what? You're going to be able to see Jeff.
Yay!
So
It's also be live streamed, I think.
yeah, I think they post these and the slides are going to be up, but we'll
Yeah.
make sure people can see it. But PyCon US, Jeff Epler's talking connecting old to new CircuitPython retro computing infant devices on modern PCs. It'll be May 19th, 1:45 p.m. 2:15. It'll be in Hall C at PyCon US 2024 in Philadelphia, Pennsylvania.
Yep. I mean, Jeff has had, last year or so, he's had a great run of just going through a bunch of cool retro devices from SNES mice to Tandy keyboards to Xerox computers to all sorts of, floppy drives and CRTs and whatnots. Getting them to all work again, bringing them back to life by mixing old and new technology, especially using, boards like the KB2040, ESP chips, and CircuitPython, which has made it really easy for him to make these mods. And I think it's a cool demonstration of the power of CircuitPython, where you can embed, assembler level PIO structures within a easy to understand and program CircuitPython script that is, quickly adaptable. Definitely one of the things about dealing with retro technology is, you're kind of half reverse engineering, half debugging, half learning. So having a fast iteration cycle is key, and that's what CircuitPython lets you do. So yeah, if you're at PyCon, of course, please go. And if you're not, then wait, and the slides and video will be posted.
And I think like one funny thing with this talk, but also I think it's important because anytime people talk about retro stuff, they're like, oh, people are destroying things. No keyboards are harmed in this. This is non-evasive. This
That's
is
another
stuff,
one of the cool things. You get to tap
it
the
just
original protocol and
it just
convert it.
works. Yeah,
Yeah.
I think that's really important. And there's lots of mods and things that people do where they like gut retro hardware, and sometimes this stuff just is broken, doesn't work. But this is working with equipment that you're not going to destroy. So you also want to talk about something else. I was asking you about it.
Couple things. Well, actually, at the very top is where we've got the
Oh, up to 750. Actually, I think we're 755.
yeah.
Certifications.
The other thing that's cool is
The
Raspberry Pi
Raspberry Pi
Connect.
Connect?
This is kind of neat because, like, one of the things with VNC is that if you set up VNC on your Raspberry Pi so that you can like view and control your Raspberry Pi remotely, traditionally you can only do it within the same network because like it's peer-to-peer, point-to-point. But now Raspberry Pi has like this service, Raspberry Pi Connect, and it's a little bit like Zoom, but for like Raspberry Pis. Can they even mention that? So because it's, if you have a Pi on a different network, like how do you know the IP address and how do you like, route back and forth and connect to it? This is a hard problem to do because everyone's behind a firewall on purpose. Um, Raspberry Pi now has a service that they run that helps connect your Pi to your computer web browser. So they've solved the little problem of like, how do you know where in the world your computer is? Once you identify it, then you can send data back and forth without touching their servers. So it's kind of a nice little add-on for Raspberry
Sort of
Pi.
like a million years ago when you're running your own web server and you wanted to use your like home cable modem connection and you needed to be able to serve up pages, but it was always a dynamic network address. It was always a different IP address. So it would be able to register the IP address and then it would be able to route to get to it so you can do stuff.
Yeah.
I'm sure this is kind of neat because now there's lots of ways to do this. You could probably do this before, but now this is brought to you by Raspberry Pi.
You could do it, but it's like very complicated and you're using like third-party services and like you have to trust them.
Yeah.
Here you're just using Raspberry
Yeah,
Pi.
this is neat. So you'll be able to log into it from anywhere, and you can
Yeah.
also
And this could be useful for like if you're running Blinka or hardware, you could connect to your hardware and controller from anywhere. It's kind of nice.
That's really neat.
Yeah.
Probably would be good for people who do home automation stuff too. Okay, and that is our Python on hardware news this week. Don't forget, delivered to your inbox every single week. Go to adafruitdaily.com.
Thanks, Blinka.
It is a completely separate website. We do that because we don't like spam either. And go there, sign up, or get on GitHub, or the RSS feed, or on the blog. Any of those places. Okay.
GitHub feed, whatever.
We have thousands and thousands of guides.
Over 3,000, yeah.
What's on the big board this week, Lady Ada?
Okay, this week, so the big project we have is knowing Pedro redid the Halo Energy Sword, now with the RP2040 prop maker Feather, which means that this huge complicated wiring is basically like now 3 solder points. It's like really easy. It's a great remake. They've also learned a lot about 3D printing and how to like make props. So the build is even better. This is, they've been going through all the guide feedbacks and, fixing up a couple broken links and stuff. And as they're doing that, they're getting a sense of what projects people have the most struggles with. And so it's good. It's always good to do remakes, especially with the prop maker Feather, which again, it's all in one, really easy to do prop projects that have audio and LEDs and battery power and charging and stuff. Also got a couple guides for some of the little breakout boards we've had recently, thanks to Liz. The PWM output Stemma board is a quick square wave outputter generator. The SEN54, SEN55 adapter, which there's an Arduino library you can use and buy the SEN54, 55 from DigiKey. And then the low power wake up timer breakout. That's an old INMPI board that we chip that we turn into a board.
All right. And then in Playground, let's see what's new over here. Here's some fun things that you can do with a Neo TRinky project. You can make some alien words. It has this babel.py, generates alien words using a set of rules. So you can do Wookiee, Klingon, Vulcan, Romulan, and all sorts of things. So let's check this out here.
It's kind of fun.
Yeah, so you can get the
codes there.
Yeah, so that displays in REPL. Stuff My Dog Said, this was one of the ones that we talked
I think
about.
it got updated.
Yeah, last week, where you can see if you've ever seen any of those little mats that the dogs talk. Well, this logs it, and you can see what the dog was talking about. This dog likes water, mommy, daddy, later potty, walk, play, and walk.
Sounds like things a dog would want.
Yeah. So do check these out. These are all of the Playground ones. Anyone can post up on a Playground. We feature these. Folks are on Show and Tell.
Yeah.
This is your free place online. We don't put ads on it. If you send a link to someone, they don't have to log in to see all the steps. It's just a cool, safe place to post up your projects. That's the guides for this week. Okay, let's do some factory footage. And a little bit of a view making here in New York. Okay, 3D printing videos. We got two. We got the Hello sword. Make sure I'm sword RP2040. And then we're gonna do a speed up. Take it away now, Pedro.
You can build the iconic energy sword from the Halo video game series and TV show. We've upgraded our original project to feature motion-activated sound effects powered by CircuitPython and the prop maker Feather RP2040. This dev board is our favorite go-to because it's designed for making prop projects. It's got the RP2040 chip with built-in audio amplifier, accelerometer, and 5-volt NeoPixel level shifting. CircuitPython has made our prop maker project so much easier thanks to our new demo code and libraries. Dev boards with CircuitPython are great for props because they load just like a USB flash drive, so you can easily edit the code and drag and drop audio files. You can customize the LED effects and change the sensitivity of the accelerometer to better fit your projects. It's got different modes of interactivity that work really well for most projects. When the prop is idle, the LEDs slowly fade with a looping sound effect in the background. When the accelerometer detects a swing, it triggers a blast-style effect with swooshing sound effects. Heavier motions trigger a bright flash of light with a harder hitting sound effect, and you'll get a bit of randomness each time it triggers. The code is easily adaptable, and because it's CircuitPython, you can make an edit, hit save, and quickly see your changes without having to compile the code. You can get the parts to build this project, links are in the description. We designed the CAD assembly to feature a more rigid structure with updated internals for housing the electronics. Free CAD files are available to download in the project's Learn Guide. The blades are 3D printed in white translucent PLA filament. The pieces feature sturdy mounting tabs that are attached together with steel machined screws. Mini skinny NeoPixel strips are wired up and fit neatly along the inside edge of the assembled blades. The speaker press fits into a 3D printed holder and is secured inside the handle along with the prop maker feather. A MIDI slide switch fits snugly into the built-in holder, and a 2000 mAh LiPo battery fits under the dev board. Wires from the two NeoPixel strips easily connect to the prop maker feather thanks to the screw block terminals. Mounting tabs on both sides of the handle are wedged into the blade that feature additional mounting holes for attaching them together. We had a lot of fun updating our energy sword with new features and think we've made it easier for folks to put together. We hope this inspires you to check out Adafruit's CircuitPython and Prop Maker Feather RP2040 for your next prop project.
All right, don't forget the code is TRRS. Let's do some I on MPI.
I on MPI.
Brought to you by DigiKey. Thanks, DigiKey and Adafruit. Here we go, Lady Ada. What is the new product introduction of the week this week?
Okay, this week it's from Infineon. Oh, this chip is actually originally from Cypress, but Cypress and Infineon
I was
merged.
going to ask that. Isn't this from...
Let's see
Because
what.
they're the great mergers.
I know, so many. So they merged in like 2019, 2020.
Right.
So this is a kind of a two-piecer. It's for the Cypress PSOC 4000 T series, but also the eval board that they have, which let me get the exact part number. It is the CY8C Proto 040T, which is a really cool cap touch or cap sense capacitive touch slider and button dev board, and I'll show a demo at the end. But this is basically about this series of chips. So these are ARM Cortex M0 chips. They're low cost. They're very small. They're M0 pluses running at 48 megahertz with 64K flash, 8K RAM. So they're not like, huge powerhouse chips, but they will run most small, goods on their own. They can act as a main processor. They don't have a ton of peripherals, like there's no ADC, there's no USB. They have two serial COM blocks that could be I2C CSPR UART. But what they do have is very, very low power and tons of capacitive touch inputs, 16 inputs out of the 21 GPIOs. So pretty much like every pin can be part of either a self-capacitance or mutual capacitance network. And another kind of cool thing is they have a built-in I2C bootloader, which I found out later. Okay, so capacitive sense is really useful when you have a device that's really small, so it can't mechanically have space for buttons, or you don't want the problems that happen when you have buttons or switches where they get dirty and they go bad and they have a life and a little bit of water gets in, and then your entire product is basically ruined because the on-off button doesn't work anymore or it's really flaky. That sucks. Whereas capacitive touch sensing can go behind a fully sealed plastic or glass enclosure. And so it's great for, especially if you can use it for your on-off switch. When you touch it, the device automatically turns on. That's kind of handy. So this series of chips includes their 5th generation of the CapSense protocol. So, capacitive sensing itself it's pretty simple. You charge an RC filter using the capacitance as the C, and you have some fixed R. But there's a lot of filtering and software that happens on top of that that actually makes it reliable. And that's the thing, is a lot of times when you have a very inexpensive capacitive touch implementation, it's not reliable and it's flaky and people get frustrated using it because it turns on or off, when it gets wet or when you brush by it. It should feel as reliable as a tactile switch without the inconsistency of life, a lifelong value of a mechanical switch. So there's the standard capacitive touchpad, this is like self-capacitance, is you have a trace going to the pin. You have a ground shield around it that, helps avoid issues with, cross-contamination of signal or water. You have an overlay to protect it. And then, sometimes you have an LED underneath or around to indicate when it's been pressed. And that pin is connected internally into the capacitive touch peripheral that can detect when it's touched. Ideally, it kind of does all the work for you. So when somebody touches it, it just tells you like, hey, it's been pressed. You don't have to do any of that filtering and software. By connecting multiple pads together, you can make a slider. These interdigitated pads, you have like 6 to 8 different pads, and then you can take a moving average across all the pads, and you can tell where the finger is, and you can, basically have a slider that you can use, or, on the 2nd or 3rd generation of the iPod, it was used as a capacitive touch wheel that could be used to, fast forward or raise the volume or lower the volume. There's also mutual capacitance, which has multiple lines, and this is often used for grids. You have an XY grid and you have multiple pads. This allows you to have, more pads with fewer connections. Also, sometimes it improves the reliability. No, so there's pros and cons. I linked to a white paper in the text that you can read the pros and cons of using self sigma delta capacitance versus mutual capacitance. But the thing that is challenging, especially if you've used like older products with capacitive touch, is that when liquid gets on them, the water droplet has capacitance in it, and it's capacitive enough that it will trigger the sensor. And so, I've seen this if you go outside when you like try to use your phone when it's wet, water gets on the screen, like suddenly it like thinks that you've touched all these buttons and stuff. Especially if you have products that are used in wet environments like a bathroom or outside or in a gym where there's a lot of sweat and people like, spilling water and damp towels, or in a kitchen, you're going to have liquids that splash on it. You don't want to have your oven accidentally turn on because somebody, accidentally splashed some water on the control surface. So it's definitely important if you're making white goods or home goods that are being used like pretty much anywhere in the home or outside or in a gym, to not accidentally turn on when some water drops on it. So what's nice about the 5th generation is it's got, not only does it handle drift, but it handles like instantaneous water droplets a lot better. So on the top is, and important to look at the Y scale because it doesn't start at 0, it starts at like 39,000 count and it goes up to 40. So the count difference is only a couple thousand counts. On the top row is, previous versions of capacitive sense implementations. At the bottom is the CapSense 5 generation. They've gotten much, much better at, detecting mist or water droplets. So like if you're thinking of, you have a pair of headphones and you want to detect when they're inserted, also when somebody's tapped them to mute or fast forward or up or, raise or lower the volume. Common use case for, fully sealed devices that want capacitive touch interfaces. The PSOC 4000 series does a much, much better job. Doesn't have the false readings, but also doesn't lose your range of sensing. So you get the full range. So you can really detect, like you have a very consistent response to capacitive touches. Another nice thing about this chip, which I thought was cool, is if you're using a Cortex M0, one of the things you're going to like is the very low power deep sleep mode. So this has an autonomous capacitive touch system where it can do wake to touch at 6 microamperes because the capacitive touch sensing system will happen like autonomously. It's called like autonomous system, happen on its own, and then we'll wake up the chip. So you don't have to wake up the whole chip just to do a reading or to do an averaging or to run the software. You'll at least get like the basic readings from that cap sense block. And so you can have like much, much deeper sleep, 6 microamperes is what they say. And that way you don't have to have a separate on off switch. You can actually just have your device automatically turn on. And then when somebody picks up or touches it, it turns back on. So yeah, this is the chain, it used to be 50 microamperes. Now it's as low as 6 microamperes. If you want more complicated interfaces, like with high refresh rate, you'll go up to like 100 microamperes or so.
And it's in stock at Educate.
Yes, the eval board is in stock. So I want to show the demo. Maybe we'll go to the overhead real fast. Okay, so this is the. Hold on. Make sure it's focused. Okay, so this is the eval board that you get. So you get the debug interface, and then this is the actual chip. And then, let's see if I can do this. So this is the capacitive touch button. So you see I press it, I touch it, and it goes off. And it's pretty good if I, have to really touch right on top of it. And then this is the slider. So as you see, as I go up and down, it increases the brightness and lowers it. And then what I did is I just had this water bottle, and I just, oh my God, there's like water all over the place. And got it nice and wet. And then what you'll notice is, I got the chip wet, which I shouldn't have done. Oh no. Too much water. Okay, so even though this is wet and it has like all these droplets, it still works just fine. And then this one also is nice and damp, still works great. Don't get water on the chip, but on the surface because it's covered with the
dangerous for a live demo.
I know. Well, I have a second one if I had it too. But you can see I'm even like smearing the water on it, and it's doing a really good job of not letting the water change the readings. So this is a really good solid capacitive touch software filter system.
Okay. And with that is INPI.
Yep.
INPI.
Alrighty, don't forget the code is TRRS. We're going to do new products and then some top secret. I can answer your questions. I've been storing up the questions y'all been asking, so that's all good. Here we go. All right.
Got some lead solder. People love lead solder. This is 6040, not for use in the EU. Americans only. It's got lead in it. It's not lead free. It's super skinny. As we go back to the previous image, you'll see very fine pitch. It's 0.3 millimeters, so very thin. This is good for surface mount, especially it's leaded. It's good for surface mount. Rework, again, it's leaded, not lead free. But if that's what you want, you've come to the right place. Next up, this is a major key alert. We've got key switches. So this is a lock that has a key that goes in it. You get 2 keys. You can see on the next image. And I'll show it on the overhead. When you insert the key, you can turn it and set it to off, or you can set it to be on. And on the back are 2 contacts, and when it's on, these are 2 are mechanically connected. It's like a switch, like pretend you pressed a button or flipped a lever. And when it's off, they're open. So you can use this as sort of an on-off switch or a signal, detector, whatever, or mode selector. But you get a key, so it's kind of like cool because you can like lock the system. You can keep people from messing with it. Only thing to mention is every lock has the same key. This is like not in any way a secure system. It's also trivial to pick. So think of it as sort of a fun interface, not as like something to secure, something of value like your crypto wallet or what have you. You drill a
Good for
quarter
props
inch.
and stuff like that.
Yeah, for props and you know, other fun things. I of course left the nut on, yeah, the nut is included. You drill a quarter-inch hole in your panel, looks like about like a quarter-inch thick, and you can panel mount it very easily and then just solder to
Yeah,
the contacts on the end.
this is cool. You're gonna be able to do a lot of neat like control boards and all sorts
Yeah.
of stuff like that. Okay, next up.
Okay, next up, we had a request to get basically what are called like hammer headers or press fit headers into the store. I'll say that, you know, there's a couple warnings. These are not magical. They don't solve all your problems. They're definitely fun. Comes in a strip of 36 pins. The issue is that you have to then insert them and they're press fit, and you can't like hand press fit. So you have to use pliers to do it. And it's like you have to get a little bit of practice. So don't expect that you'll be able to use like every single pin. You might have to try 1 or 2 times until you get the hang of it. But I can try doing a live demo. So I grabbed the wrong board, but maybe it's okay. So yeah, go to the overhead. Okay. So I usually don't do this many pins, but maybe I'll do like 8 pins. So you can.
Too risky live demo.
I know, it's kind of risky. So I think I got the right number. Yeah, there you go. So if you tried to press fit this, you can't. It's actually like your hands can't do it. You can't even do it like this. You can't like press down. You do need to use pliers, and you can sort of like
That's not too bad.
slowly work your way down the
Yeah,
row.
something like press fit solder free headers.
Yeah. And then when you're done, you'll see they're like a little bit uneven. Then that's when you would,
Yeah, then you can press.
you could try to press to flatten them, or you can, you know, you can
That's
try,
yeah.
yeah, you can try pushing each pin in. And so when you're done,
Looks pretty good.
as long as you see all the holes coming out, that mean, and you know, this is not quite perfect, but it's good enough. This is actually quite solid, so it's in. So I'm just going to warn you, you know, it takes a little bit of effort to get the hang of it, but it does work. And then you can snap these apart up to, you know, 36 pins, so you snap as many as you want. And then when you're done, some people ask, can you solder them? Yes, you can just solder it when you're done, and then you have like a really good mechanical connection.
Yeah.
But if you want, you know, you can pull them out too. I would recommend you pull it out pin by pin. There you go. Just yank it out, and then, you know, it's kind of
Tossed
destroyed.
it.
But yeah, and then after you push the pins in, of course, use a multimeter to check the continuity to make sure that you really got it all wedged in all the way.
All right, cool. All right, next up.
Okay, next up, by popular demand, we now have a tripler for the Raspberry Pi Pico series. The Pico, Pico W with headers, Pico H with headers, and Pico bells. So you can now have 2 accessories, or like 1 accessory and just a lot of extra prototyping space for your Raspberry Pi Pico boards. And we add all these little extras as well. So if you can either go to this image or you can go to the overhead, and I'll point out all the things. Okay. So you can, all the pins are duplicated across. So like, you know, you can use any slot. All the slots are the same. And the Pico goes in the middle. Probably should have grabbed one. And then you have an extra row on the outside of each one. So these are nice, solid mechanical connections. All the pins are labeled on the side here, so you can see all of them, and on the back as well. No, actually, sorry, they're not. But they use what pins are available, and the connectors are on the back. And then you've got Stemma QT connector, so you connect I2C sensors, Quick or Stemma, or, you know, PICO or whatever you want to call them. Anything that uses the JST 4-pin connector. You have a NeoPixel connected to pin AD2, which you can cut the trace if you don't want the NeoPixel. Battery charging. So you can add a LiPo battery here, and this is a charging circuit. It will automatically charge through the Raspberry Pico's USB. You have 2 status LEDs as well, green and red. Green means it's charging. Red means, sorry, orange and green. Orange means it's charging. Green means it's done. You can change the rate. By default, it's 500 milliamps. but you can cut and this trace to make it 250 milliamps. You can also disable the charging. So if you want to run your project off of AA batteries, so you obviously don't want to charge them because they're not rechargeable LiPo, cut this trace to disable the charging. And enable switch. So with this switch, you can enable and disable the 3-volt power supply. So this switch connects to the N pin over here, which is the built-in enable. Reset button does exactly what you think. You can reset your Pico because there's a reset button. And then everyone's favorite, the iSpy connector. So this is a very skinny, it looks like it's too skinny, but it is a full iSpy connector on the end here that allow you to connect TFT displays. And the pinout is labeled over here. So use a lot of pins. You've got SPI on 18, 19, and 16, the data command and TFT chip select on 20 and 21. A lot of our breakout boards for TFTs have an SD card. You have the SD chip select on 17. If there's a touch screen on the SPI port, the chip select is on 15, interrupt on 22, and the backlight on A0. So you'll notice the reset and busy pins aren't connected. So this is not ideal for e-ink displays. I'll say it's just, I couldn't route it and there weren't enough pins. And I sort of, decided most people wanted TFTs anyways. So you can use, you don't have to use all the slots if you just like, oh, I like the iSpy connector, put your Pico in the middle, and then you get all these fun accessories and you can connect wires to all the pockets if you'd like.
All right, and then tonight, Star, besides you, Lady, our team, our community, all the people who share open source and make the world a better place to bring people together through science and technology and engineering and more is
it's the TRRS TRinky for assistive technology, shown here with the Xbox. Oh, can you show the top because the keys, the letters aren't visible.
Oh well.
You know what I mean? Like it's cropped.
Oh, it's cropped out. That's fine.
Yeah. Okay. Yeah. So you can see the A, when they press the A button, the A gets typed, and when they press the B button, the B gets typed.
We'll even zoom in now. So it's right here.
Okay, great. Thank you so much. So this is a programmable SAMD21 TRinky board with a nice USB-A connector. It's got like a reset button, so you can enter in a bootloader. You can program it with Arduino or CircuitPython. There's a little Stemma QT port, a NeoPixel, USB-A jack. You can use an adapter if you have a C port. And then most interesting is the TRRS connector with two switches on the tip and ring contacts so that you can detect when it's been plugged in. And a nice mechanical connector as well. And all of the pins from the TRRS jack are connected to analog inputs on the SAMD21. So no matter what kind of assistive tech switches you're using, whether they're like potentiometers or you want to use a splitter to connect multiple buttons, you can connect up to 3 switches or 2 potentiometers or like 1 potentiometer and 1 switch because you have 4 contacts and they're fully configurable. And the idea here is that you would be able to reprogram this to customize it with Arduino or CircuitPython. So it doesn't come with like a scripting language or like a desktop program to configure it. It's kind of your, whatever your dream is, you can make it happen. But it's like open source hardware and it's inexpensive. So if you want to make a custom design that uses like cording or maybe uses other I2C sensors for a combination of having AT switches and maybe like a sip and puff sensor, this is a little board that you can very easily get up and running. It's minimal and you plug it right in so you don't need any extra cables. And with Arduino or CircuitPython, you can very easily program it and configure it, use it with your mobile device, use it with desktop. So hopefully this will make it very easy for people to do AT switch projects without needing like any wiring or like a separate Arduino or cabling or whatever. It's all in one, very compact.
And check out whatever Bill is going to do with this is probably what you want to do with it. So AT makers, this is kind of made for them.
But I think also like anyone who is like, oh, I want to add a switch input, it's like you don't necessarily need to have a AT project for it.
Yeah,
You know, if there's
we get
people
tons of
like, "Oh,
ideas.
I want to just add a switch input and I want the switch to be made out of like, you know, 2 pieces of cardboard with laminated tinfoil, you know.
And if you're in Discord, or I'll just repeat it now so you can hear this, Bill says it can completely emulate the Xbox adaptive controller's input, to make it super handy. Yeah, so there you go.
Yeah, you can basically, because it's a full SAMD21, you can have it act like any device. You can have it
Yeah.
act like a MIDI device. You can have it, you know, talk to Android or iOS or what have you. It's you know, fully open source and programmable, so a customizable solution. And you know, we're going to publish the files, so you never have to worry about this technology getting discontinued. You'll always be able to make it.
Okay, and that is new products for this week.
Okay. New.
Okay. Now you see why the code is TRRS.
Church.
TRRS. Okay, we're gonna do top secret, and then I have the questions already lined up,
Yeah.
so we'll get to those. Let's
Great.
do it. Okay, let's play these videos. All right, lady, what's this?
Okay, so one of the benefits of working at Adafruit is that you get to ask for hardware, and I'll usually build it for you, and we'll put it in the shop. So one of our Adafruit IO devs asked, hey, they want to wire up DS18B20 temperature sensors, but they want to wire up a bunch of them for quick testing with like a plug-and-play system similar to Stemma QT. So here is, you know, this is like a plug-in Stemma cable. So you see it's got the pins just wired up to a Metro. And then you can chain these boards together. So here's like one, and then here's another one, and then there's like a third one. And then the fourth one actually has like a cabled version of the DS18B20. And each one of these has a screw terminal block, so you can easily attach and detach. And you can use it with 2 wires, only ground and signal. So this is purposefully disconnected to show like you can still read the temperature even when the power pin is not connected, because it's using parasitic power. A little red LED that's buffered here, so you know when signal is going through. And then on my serial monitor, you can see all the temperature data coming through. So yeah, about 25 degrees Celsius for all of them, room temperature, all of them are working. So a little handy solder-free way to quickly wire up lots of DS18B20s. Coming soon to the Adafruit shop.
Lady Ada, what is this?
Okay. I've been working on improving our soil sensor board to add a Stemma QT port. At the same time, I was like, well, why don't I make like a TRinky board, something that has a SAMD21, an HT20 temperature humidity sensor, a NeoPixel, a light sensor, USB-C for programming it in Arduino or CircuitPython, Stemma QT port, and then QT mounting hole, so you could like attach another Stemma QT sensor. So here it is in this lovely $6.99 roses flower pot from Trader Joe's. Beautiful. Got this morning. And I'm measuring the soil sensing using the capacitive sensor. You can see the 2 pads here. And like I said, temperature, humidity, and light. And here's what it looks like I'm uploading the data to Adafruit IO. So if you look over here, you can see where I kind of pulled out the soil sensor for a second just to reseat it. But what I'm going to do is plot this over the course of a couple of days. And that number should dip from 200 down to 0 as the soil gets drier and less capacitive. And then maybe I'll set up an Adafruit IO alert to let me know, and I'll water the plant. So yeah, a little all-in-one plant monitoring system. So hopefully it won't kill plants as often.
All right, what's this?
I needed a quick way to like disable data lines or the power pin or the ground pin on a USB connection. And I was like kind of DIYing it with a cable. But then I was like, oh, maybe I should make a little board that has like little slide switches. And so I made a board that has little slide switches so I can like quickly disable any of the connections.
Okay, next up.
Get a request for an I2C to 1-wire converter. So this will allow like single board computers that need 1 wire, or if you have a microcontroller that doesn't have 1 wire but does have I2C. There's libraries available for the chip. Apparently it's kind of cute, and apparently this one has ESD support as well.
Okay.
Your protection. I had a request for like a, you know, easily mountable NeoPixel LED that had like, you know, mounting holes and didn't require any soldering. So this version has JST SH connectors. on the bottom, like little tiny connectors. You know, it's not going to be inexpensive, but if you only have to mount a couple LEDs and you don't want to do any soldering, you just want like something plug and play, so you can like easily remove and replace them if necessary. I think this could be a good design.
All right, and that is top secret.
Yay!
All right, don't forget to go to TRRS. We're going to do questions. We got a bunch. They're lined up. A couple of these might have to go into the forums because it's not. It's like.
Well, maybe we'll just do.
Code, but
We'll do fast.
Well, we got them.
Okay.
Okay. First up, it seems I can't use NeoPixel on the RP2040 host feather if I'm using PIO USB host code. Is that because PIO state machine conflict? I know both use PIO.
Yes, the USB host uses all the PIO. So you can use NeoPixel, but you'd have to bit bang it. So yeah, it's a little annoying, but that's the trade-off of using bit bang USB host.
Okay, this was answered in the chat, but I'll go over this too. What is recommended for adding flash capability to the Memento board for night pictures when activated by PIR? There's ring.
The LED ring add-on,
Yeah.
it's absolutely, if you have the
It
right
gets
LEDs at 100% brightness, it is bright as hell. You can just turn that on and illuminate everything. You don't even need a flash. You just turn it on to light up what you're
A
shooting.
couple people noted the Pi Connect. Yep, it's like Team Viewer or Go to My PC.
Yeah.
From the NPI section, does that help with oval sensors?
You can definitely use oval sensors with that chip. Yeah.
From the MPI section, could that Cypress 4000 chip go on a Stemma QT as a cap touch sensor? Is there a I2C interface that it could go?
I would use one of the,
Suppose.
there's all-in-one Cypress, like they make a I2C chip that does capacitive touch sensing.
Okay.
Like you don't need the Cortex M0 part. It just does that with I2C register.
Okay.
So I wouldn't use that chip. I would use a different one in that family.
Are those headers available in 90 degrees?
I don't think so. I think this is kind of, it took me a while to find these.
Is there an alternative to OpenOCD that runs on a Raspberry Pi?
No, it's, yeah, it kind of sucks.
Okay. And then
That's
this
what it
one,
is.
this person had 4 questions. So some of this might have to go in the forums, but you can see I'm dealing with speed issues with the DotStar library and building a spinning LED pop-up display. I would need to reinvent the DotStar library to solve my problem, which is not entirely open source. Most of the private code library is astronomically useful. Going deeper, strip.show. In the DotStar library with CircuitPython, C++, same speed. I'm using Adafruit ESP32S2 Feather.
If you really need speed, what you want to do is, yeah, you want to DIY it as an SPI DMA transfer, and you wouldn't block like you would do the transmit, and then you'd have to later on keep track of when you're done because you'd have a DMA transmission that you wouldn't block on. If you really need that kind of speed, you're going to have to write that code yourself because we don't allow that because it's dangerous. You could easily, not dangerous, but it's like you could easily be confused because you're like, oh, I'm trying to write to the DMA peripheral while it's still transmitting. So yeah, optimization, you're going to have to tweak the code yourself.
Okay, is there any other documentation for CircuitPython? So it's circuitpython.org, all on learn, and then we also have read the docs.
Read the docs, Discord, weekly
You
meeting.
could do the Ask the Devs in Discord and then join the weekly developer
Yeah.
meeting that we do. Why does microlab.numpy not support an array with more than 2 dimensions? Normal NumPy does. Might because it's
Because it has to fit.
controllers.
Yeah, it has to
It's
fit on
fit
the
on it.
microcontroller.
Yeah. Next up, this is not a question, it's more of a request. IDE over Wi-Fi for over-the-air updates.
We do have web workflow. The question of whether we could do over the air, basically, nobody has really been interested in it because we have this web workflow. Secondly, it's hard to do over the air well, and it's hard to do over the air with a very big program like CircuitPython because you basically have to use like a ton of the memory, and we have, CircuitPython is a gigantic program, and so while there is an over the air partition, we kind of want to get rid of it because more people want functionality in CircuitPython than over the air.
Okay.
And if you can't have both,
Do you know if the phone?
small flash memories.
Do you know if the phono library also works with the new SIM4G chips like the SIM 7600 series?
You probably have to make a small change to the library, but you can make it work.
And then driver for the INA 228.
It's in progress.
Okay. I think that is it. You speed rounded it. Okay, good. Looks like folks got oh yeah, also GitHub for more documentation because that's where we keep CircuitPython code. Okay, I think that is everything. Good,
Okay, great.
good job, speed round, Lady Ada.
Yay.
Okay, everybody, don't forget the code TRRS.
Thank you.
TRRS, sorry.
TRRS.
Has been an Adafruit production.
Thanks, everybody. Have a
See
great day.
everybody next week. Here is your moment of Xenon.
Bye.